Dr. Nardi here, back with another video. And in this video, I want to talk about the role of the scientific method in psychology and how important science is in the field of psychology. Now, a lot of students think, when they think psychology, they think pop psychology tests. And we're not talking about this. We're not talking about going into Barnes & Nobles and looking for those self-help books. Or maybe you've gone online and you've taken quizzes like what breed of dog do I most resemble? Or what's my love profile? Or are you actually a hipster? Or which Ryan Gosling character is your soulmate? Again, these are really cool and fun, but they're not what we're talking about when we talk about scientific research in psychology, specifically what we focus on in the psychology field. These are what we call pop psychology. And I want to make that distinction and why the scientific method is important. Now, a couple things I want you all to think about is true or false questions. And I'll give you a second to answer these. And you could think to yourself. I'll go with the first one. Individuals learn better when they receive information in their style of preferred learning, like auditory learners, visual learners, or hands-on learners. Now, is this true or false? If you said to yourself, this is true, you'd be 100% actually incorrect. This is false. This is not based on science. It's very popular to say that, but people don't learn that way. And we'll talk more about how people learn a little bit later in the course, but it's really about repetition and seeing things and hearing things at the same time, seeing things in dual modalities as we talk about. What about this one? A common sign of dyslexia is seeing letters backwards. That's actually false as well. That's not true either. It's a common misconception, but it's not based on the research. Again, a lot of these misconceptions exist because of the lack of scientific understanding. How about this one? Listening to classical music increases a child's reasoning ability. This one is also 100% false. Listening to classical music does not make children smarter or be able to reason better. It actually has no effect on their reasoning ability at all. But as we'll talk about later, sometimes the news gets a hold of things and then they misinterpret it and then there's a runaway story. How about this next one? We only use 10% of our brains. Well, what do you think? This one actually is also false. We use all of our brain depending on what task we are doing, and certain parts of your brain light up, certain parts of your brain actually light up to suppress other parts of your brain. It's a very complex system, but this myth is busted. What about this one? Children are less attentive after consuming sugary drinks and snacks. Ooh, if you said true, you're incorrect. It's actually false. These are all false. It's not the sugary snacks that makes kids less attentive. Or makes them act hyper. It's really that expectation and also tying it on to something they're looking forward to. But we'll talk more about this and we'll talk about more of the role of the scientific method in psychology. So stay tuned. So let's talk about some bias in your thinking. If you looked at this picture and I asked you which monster is larger, which one would you say? If you said the one in the back, actually, you'd be incorrect. They're the same size. This is a bias in our visual system based on the tunnel, and the one monster looks like it's farther away, so it must be bigger. But if I were to remove these lines and put them next to each other, they're literally the same size. So we have limited processing power. So our brain takes shortcuts. It takes shortcuts to get to answers. And sometimes it leaves us with a bias in our thinking. Like, for example, your book mentions the availability heuristic. That's your ability to basically judge the probability of an event based on how many examples you can think of. A great one of this is if you think, oh my gosh, if I go on a plane, it's going to crash. And you might think that because what do you see on the news? You see plane crashes. You never see how many planes land safely. But you can think of multiple occurrences of planes crashing, so you think it's going to happen a lot. Again, that is incorrect. And research, if you actually look at the numbers, you would notice that plane flight is very, very safe compared to other forms of transportation. Another one is a gambler's fallacy. Now, this one is very interesting. It's basically, if you flip a coin, heads or tails, right? It could be heads or tails. You have a 50-50 chance. And let's say you get heads the first time, and then you flip it again, right? And someone say, well, if you got heads, the next one should be tails. Not realizing that these are a series of independent events that are not related. There's no correlation between each other. So that's another thing you want to be wary of, is independent events in time. The other one I kind of want to mention, and I want you to think about this to yourselves, is imagine your neighbor asks you to help her figure out someone she has met named Steve. And she gives you some clues. And she said Steve is very shy and withdrawn. He is helpful, but has little interest in people or the world of reality. He's a meek and tidy soul. He has a need for order and structure and a passion for detail. And your neighbor also tells you, oh yeah, Steve, he's just some random guy she picked from a larger population. And she asks you, is Steve more likely to be a librarian or a farmer? How would you answer her? Now, a lot of my students would say, oh, has to be a librarian. And I'd say, why? And they'd say, well, he likes order, he likes structure, he's meek and tidy. I think he's a librarian. And again, sometimes we take shortcuts, right? And sometimes we draw incorrect conclusions. And if you said that, you most likely would be wrong based on the numbers. There are way more farmers in the United States than librarians. So the chances of him being a librarian is very low. But if you actually look at the data, you would say, oh, yes, he has to be a farmer. Even though a lot of people would jump to the conclusion that he is a librarian based on their own cognitive biases, based on their own conclusions. Often we use what we call a heuristic to get to an answer. And you might say, oh, this seems to make sense. We look for patterns as individuals. So you might be trying to make a pattern and you think, well, I see a pattern in this, and there we go. And unfortunately, you'd be incorrect. There's one other bias in thinking I want to talk about, is confirmation bias. And that's usually people's tendency to look for information that confirms their own beliefs. We often like to be right. And what happens sometimes is we'll look for information that confirms our beliefs about something, happens to scientists, and we'll ignore anything that disconfirms our beliefs. So we have to be careful of that issue as well as the other biases in our thinking. And one way we can be careful about that is using the scientific method. Now, before I get to the scientific method, I want to talk a little bit about epistemology, because that's a big topic, right? And it's just really ways of knowing, right? How do we know about the world is the question. Now, there's often tenacity or tradition, like we know things because that's the way it's always been done, right? You do this because your parents did this, right? You have this tradition in your family. Why do you do it? It's been passed down. Sometimes we know things because personal experience. You've experienced something, so you say, oh, this is how I know about the world, is through my personal experience. You could also rely on authorities and experts. Now, this is good in a lot of cases because sometimes we don't have the capacity to kind of maybe, especially with experts in science, to do things for ourselves. Like, for example, you've heard of Einstein's E equals mc squared. Unfortunately, I cannot do the math behind that, so I'm going to have to take some people's word on it who can do that kind of math. So authority and experts are important. Intuition is another way we know. You know, that gut feeling, right? You feel like, oh, you kind of have that feeling and you think, oh, I should do this or that. That comes within. That's a way we know. We also can try to use logic, right? We try to reason through things. And the last one, and the most important one for this course, is the scientific method, or the scientific process. The goals of science can be looked at as this. We try to describe human behavior, we try to explain human behavior, and we try to predict human behavior, and finally we try to control human behavior. Now, you ask yourself, what is the difference between pseudoscience and science? Well, let me tell you about the tenets of science first, and then we'll come back to pseudoscience. So the tenets of science is determinism, meaning there is a correct answer for everything. Empiricism is just getting at something through observation, or observing something yourself. Science should be able to be replicable, meaning you should be able to reproduce the studies. It should be falsifiable, meaning whatever question you ask in science, you should be able to be proven false. So if you propose a question, then you should be able to be proven false. And some questions fall within science, and some questions fall outside science. The last one is parsimony. Now, this usually just means the simplest answer is usually the correct answer. Not always, but most of the time. If you have to get to too many assumptions, usually that's not a very good theory. And let's talk about the scientific method just briefly, just in case you all do not remember. But the first part of it is you identify a problem, you determine an area of interest, you review the literature, you look for new ideas, and you develop your research hypothesis. Once you do that, you develop a research plan. So you define the variables being tested. You have to be very clear on your operational and conceptual definitions. You identify the participants or subjects and determine how you're going to sample them. You also select a research strategy and design. And then you have to always ensure you evaluate the ethics and obtain IRB approval, or Institutional Review Board approval. Then you conduct your study, right? You execute your research plan. Then you use statistics to analyze and evaluate your data. And then finally, you have to, as the scientific process, we communicate our results, usually written or poster form. And we usually go through the peer-reviewed process I've talked about before. And we want those to be published. And then at the end of your study, you often you talk about your results, and you see if your results support your hypothesis. And if they do, you usually expand or refine your idea, or if they don't, you often expand your idea to something else. Or you might reformulate a new idea. Now, I have a question for everybody here. Are there any pet owners? I bet there is, right? Have you ever noticed that your dog or cat is happy to see you when you come home? Like they run up to you and they get all excited and they bark and they wag their tails. And you probably notice that animals form strong attachment to their caregivers. You might think, wow, animals really form attachments. We're talking cats, dogs, right? And you might assume your dog or cat, your animal's happy because you feed them. Because a lot of early researchers used to say, oh, animals bond with people because they get fed. Now, if you thought that and you weren't using the scientific method, and they didn't do that many, many years ago, back in the early 1900s, they thought, oh yeah, this must be the case. And that's just basic logic, right? But unfortunately, logic can be wrong. And what researchers did is they set up an experiment. This is called the cupboard theory versus contact comfort theory. Now, the cupboard theory was early theory, as I mentioned to you all. And basically, they said the mother was valuable to a baby mammal because it's a source of food. The baby gets food from the mother, and then experiences pleasant feelings, and that's why it attaches to the mother. Contact comfort theory was babies attach to the mother because they receive comfort from touch. And this theory was tested. And put to the test with a rhesus monkey. And he was put into a little cage, and the monkey could choose between the monkey, the quote-unquote mother, the wired mother, with a bottle, and a fuzzy mother that was soft to the touch with a light bulb in it, so it's warm. And the researchers at the time thought, oh my gosh, the monkey's going to stay with the bottled monkey because it gives it food. However, what they found out was against their logic and intuition. It was really the monkey stayed with the soft plush monkey. And sometimes it would scare the monkey with putting toys in there, and the little baby monkey would jump onto the mother and hold on to it for dear life. And this was the work of Harriet Harlow, in case you were wondering. And what this shows you is science can help defeat some of these intuitions or beliefs we hold. And that's why the scientific method is so important. So let's talk about the scientific filter very briefly. And how the scientific filter works is all ideas are out there in the world. And your scientific training, your concern for your professional reputation, and to be honest, the availability of funding, it filters out nonsense. So you're not going to pursue some nonsense research. You want to get funding and you want to have a good reputation. So this leads you to your initial research projects. And then you get to the second filter, which is your self-judgment about the viability. Can this be done? Is this a dead-end topic? Is this a fringe idea? If it is, you stop, right? And if you have a good idea, you can create a research program around this, and you conduct your study, right? And you send it off, and you write up your results, and you send it off to that peer review process is filter 3. And this filters out errors that maybe you make in your research, or biases that come out in your research, or maybe your research is just unimportant to the scientific community. It gets removed. However, if it makes it, it becomes published. And then, right, you as the person in filter 4 can read these published results, and you can then apply it to your own research. So this is the filter. This is the scientific filter that is so important to our field. So I want to talk to you guys briefly about the Mozart effect, which I mentioned very briefly early on in this video about listening to music and making children smarter. In 1993, a researcher found when students listened to Mozart for 10 minutes, they performed better on a spatial intelligence testing compared to those who listened to silence or a monotone speaking voice. However, listen to that conclusion. They did better, right, on one spatial intelligence test. However, headlines read, listening to Mozart makes you smart. Now, this was very different than the scientific study that was published. And there's only one study in 1993. Unfortunately, people ran with this. And the fascinating thing is there was a political impact to this. On January 13th in 1998, Zell Miller, the governor of Georgia, announced that he proposed the state budget would include $105,000 a year to provide a CD to every child born in Georgia. And it would have basically classical music on it. And what they wanted to do was make children smarter by listening to Mozart. Now, unfortunately, the scientific evidence doesn't support this claim, but unfortunately, the individuals writing and interpreting some of these studies, which is usually the media, don't have a background in the scientific literature, and politicians often don't. So this becomes a runaway effect. And you might have actually heard that rumor before. Listening to Mozart makes kids smarter. It doesn't, by the way. And what happens sometimes is, this is a fascinating thing, but you do your study, right? You take this class, you do your research, you perform your own study, and you run it, and you come to your conclusions, right? And maybe your university press office publishes your study and says, hey, you did this, that, and the other. And then unfortunately, the news organizations get it, and the internets, I like to call it the internets, get it, and then you see it on cable news, and then you see the local news, and all of a sudden your grandma hears it, and she doesn't understand what you're talking about, and it gets so twisted that it doesn't make any sense anymore, right? And she puts on a tinfoil hat and says, wearing this tinfoil hat wears off A or B, right? Again, it had nothing to do with your research, but the problem is scientists understand the research, but unfortunately the media and the lay people do not. So that's why it's so important to understand science. The great news is if you take one psychology course, it's been shown that people learn to examine their scientific evidence for their beliefs, and they perform much better after a psychology course. So they're able to think more like scientists when they think about their own personal beliefs, and that's what I want you all to do as well.